We now find the partial derivative of this expression w equals 8xc multiplied with x plus y raised to the power of minus 1. So here we can consider the first expression as f and the second expression as g, that is x plus y raised to the power of minus 1 as g. Since we are going to find the partial derivative with respect to x, we treat the other variables, that is y and z, as constant. So according to the product rule, the partial derivative of w with respect to x is we have to find the f prime, that is a derivative of f multiplied with g plus the derivative of g, which is g prime, and multiplied with f. So let's utilize this formula. So therefore we can write partial derivative of w with respect to x, and this equals, we have to find the partial derivative of f prime. So let's do that here. We have f equals 8xz, and we find this partial derivative of f with respect to x. When we do that, we treat z as constant. So here we have 8 and z as constant, which means this will become 8z, and then we have to only find the derivative of x with respect to x. Derivative of x with respect to x is 1. So basically this becomes 8 times of z, which we can substitute into the formula. So therefore this becomes 8z times of g. So we replace g as it is, that is x plus y raised to the power of minus 1. And then we put plus. We then find the g prime, that is a partial derivative of x plus y raised to the power of minus 1. So let's do that here. I'm going to write g prime equals x plus y raised to the power of minus 1. We find the partial derivative of g with respect to x. So I write down this as g prime. This equals, we can use the power rule here. So when we do that, we put the power in front and raise the expression to the power of minus 1, which becomes minus 2. And then we have to use the chain rule to differentiate x plus y with respect to x. So when we do that, we get just 1. So basically, this expression is simplified to negative of x plus y raised to the power of minus 2. So I'm going to write down here, just remove this expression a little bit here. Okay. This is minus 1. We had a minus 1 here, plus x plus y raised to the power of minus 2. We have a negative here. I can put a bracket here, and then multiplied with f. F is 8xz. So I write down 8xz. Now let's simplify this. So this becomes 8z over x plus y raised to the power of positive 1. This x plus y raised to the power of negative 1, I'm writing this as 1 over x plus y. And here we have plus into minus is minus. And then we have 8xz multiplied by x plus y raised to the power of minus 2, which can be written in the denominator as positive power. So therefore this becomes x plus y raised to the power of positive power 2. Now the LCD for these two fractions is x plus y raised to the power of 2. So we have to multiply the first expression by x plus y and divide by x plus y. So when we do that, we get 8z times of x plus y divided by x plus y quantity squared, minus of the second expression. We will not have to multiply. We can keep them as it is. This becomes 8xz multiplied with x plus y quantity squared. Now we have a common denominator, that is x plus y quantity squared. So we can simplify, that is 8z times of x plus y minus of 8xz over x plus y quantity squared. Now we can distribute this 8z into the expressions, that is this becomes 8zx plus 8zy, and then we have this term minus of 8xz over x plus y quantity squared. So we see that we have a common term, that is this is 8zx and this also 8zx. These two are like terms, so we can cancel them. And finally, we have the expression 8zy, or we can write down this as 8yz over x plus y quantity square. So this is the final expression for the partial derivative of w with respect to x. Now let's fill the appropriate expressions in the box. So in the first box, this is with respect to this step. So which means we have x plus y raised to the power of minus 1 times of 8 times of z. So the z comes into this first box. And in the second box, it is basically this expression. So we have 8z times of x plus y over x plus y quantity square. So we can put 8z times of x plus y. So here also we get z. And finally, in the final box, we write down the simplified expression, that is 8yz. So here it should come 8yz over x plus y quantity square.